Okay, this is lesson 83, number 8. Lesson 83, number 8. So the other part of this where I talked about how I got to this point is on the lecture video for lesson 83, but I can't go over 10 minutes. So anyway, we decided that this is the period, so that's good. So we took care of the phase shift, we took care of the period, we took care of the amplitude. So we're kind of good. I would love to just leave it like this. I kind of feel like I should stick the y-axis in there somehow, but I mean, so I guess I'm just going to sketch kind of a really sketchy looking y-axis in there just to show that it got moved right by 45 degrees. That's not very accurate at all, but I just sketched it in there. I think the main thing is that we're showing the amplitude and we're showing the phase shift. That shows phase shift. We're showing the period. Okay, so that's good enough for 83, number 8. There was something else I was supposed to do. What's another problem that's on here? So we wanted to do 83, number 8. Oh, it's not even 83. Sorry guys, it's 84. 84, number 8, and then I guess I'll have to get out your little assignment sheet to see which other numbers I'm supposed to do. Here's 84. So number 8, number 10, I need to do number 10. Wait. 8, 10, and 12. So we'll do 8, 10, and 12. Okay, so let's do number 10. So number 10 is, it's one of those show ones that I like. So it's cosine x minus cosine x sine squared x equals cosine cubed x. Alright, there it is. So we're going to show. It just says show. So that's when we're playing. Remember, we learned the rules of the game. This is the game. So we want the left-hand side to end up looking like cosine cubed x. So since the author of the book already kind of just showed us that factoring might be a good idea, I'm going to go ahead. I see this obvious, something obvious that I could factor out, the cosine, right? And then I got sine squared x. Now that's an identity, I'm sure. That's probably, this is so easy. So I already recognize that as my Pythagorean identity. If you don't recognize it, I can show it to you on your, it's this one right here. Cosine squared x, if I brought the sine squared x to the other side, see how it would be 1 minus sine squared x? Well, that's what I got right there. So that's the same as cosine squared x. So now we're kind of done. Cosine x times cosine squared x. Well, that's equal to cosine cubed x. Cosine cubed x equals cosine cubed x. So that's a fun game. That's number 10, and then we said we had to do number 12. Number 12, it's just another one like it. So cosine of negative theta, and then cosecant of negative theta, and that's equal to cotangent of negative theta. So we learned, a couple weeks ago, about even functions and odd functions. And if you can remember, cosine was an even function and sine was an odd function. So even functions, if you put in a negative value, it kind of comes out positive. It's kind of like, it reminds me of squaring something. When you put a negative in, the answer ends up positive. And the odd functions kind of remind me of like cubing something. When you put a negative in, you end up with a negative. So on this even function, since cosine's even, if I put in a negative angle, it's going to give me the exact answer as if I would have just put in that same angle but positive, so I can just change it. Cosecant is the reciprocal of sine, and sine is sine is odd. So I'm going to actually get a negative, like this negative sign can come out. But when I bring it out, I'm going to bring it way out here. And I'm just going to go like that. Now really I could, now I realize that I could probably write cosecant as 1 over sine, and then I'm going to kind of be there, right? Cotangent, cotangent is going to be odd because it's like cotangent is, what is cotangent? It's cosine over sine. And you have a even and an odd, even divided by odd. So you're going to have an odd. So this is an odd function. Actually, I shouldn't have even changed that side. I should have left it alone because that's kind of the rules of the game. But so this thing can be written as 1 over sine, and this is written as cosine theta. And then I can rewrite this whole thing as cosine theta over sine theta, and that's equal but we know cosine over sine is cotangent, so we can just say cotangent theta equal to negative cotangent theta. So there's that. Maybe we could put it back in. Since it's an odd function, we could put the negative sign back in if we want. I think that's okay. That was number 12. And then, was that all? Where did the thing go? That's it. Okay, all done. That's your lecture.